Okay, so we're gonna go over the Unit 1 review. This is probability in two-way tables. Remember, you guys have to be taking your tests. You can get 100% progress, and if you don't take your tests, you will not pass this course. Same thing, even if you get 100% on the first test or anything like that, if you don't complete your progress, you probably won't pass this course as well. So it's gotta be a combination. You gotta complete the lessons, and you still gotta do well on the tests. I'm going to go over the review. Some of you guys are skipping the tests, which I don't know what your plan is, but just know that you have to do them eventually, okay? So Belleville High School offers classes on 3 different foreign languages. Let A be the event that the student is 11th grade. So I'm looking at 11th grade is my event A, right? And then let B be the event that the student is enrolled in French class. So I'm looking at that for B, right? This is B. B. Which statement is true whether A and B are independent events? So looking at this, if I want A is independent with B, I'm looking at the probability of A given B is equal to the probability of A. So we need to determine that, right? We need to determine that if that's true, or maybe they're not independent, right? So if I look at the probability of A given B, if I am given B, that means I am given French class. French class is already like a done deal. So that is what I'm looking at. So my probability is going to be the overlap, A and B right here. This is 68, given that it's B, so out of the total, which is 272. When I do this, if I divide 68 divided by 272, I will get 2500, or this will simplify to 1/4. Right. If I find the probability of just A, right? So if I'm looking, let me go this again. This is, if I'm looking at just A, the probability of A, then I'm looking at A compared to the whole total, right? So that's the normal simple probability that we learned supposedly in middle school, right? So probability of A is probability of 11th grade. This is 138 out of the total, which is 552. When I take that on my calculator, 138 divided by 552, this will give me as well 2500, right? So because these two are equal, because they are equal, that makes them independent events, right? If I were to look at the other ones, so just for more practice, the probability of B. So if I'm looking at the probability of B, which is this one, French class, then I'm looking at the probability of B, which is 272, over the total, which is 552, because nothing's given, right? So I'm just using that. 272 divided by 552, this is 4,900 and some change, right? And then looking at those, these two are not equal to each other. But even if we were to look at it with the probability of B, then it would be flipped. Cool. Question 2. So Juanita has a storage closet at her shop with extra bottles of lotion and shower gel. Some are scented, some are unscented. If she reaches into the closet and grabs the bottle without looking, right? So think of a closet. It's got lotions, it's got shower gel. Some of them have scents. Some of them are just plain. And you're reaching, she's going in a closet without looking. Don't know why, but she grabs a bottle, which is very scary. She has a 42% chance of grabbing a bottle of shower gel. So again, if we want it to be independent, what we're looking at is shower gel and scented. So if we want this to be independent, you want the probability of shower gel, right, given that it's scented, to equal the probability of shower gel. That's what makes it independent, right? So same thing, I was looking at examples online, like if I flip heads, right, the next time I flip a coin, that one does not matter, right? It's the same probability for that. So they already give us the probability of shower gel. That right there is 42%. right? So if they're independent, they need to be equal. So this one right here needs to be 42% as well. And that's where you get it right here. Cool. Number 3. Okay, so usually when I see something like this and a table that is not filled in, I want to fill it in, right? So going across the top row, if I roll like this top row, all of this has to equal to 125. So I'm going to take 125, I'm going to subtract everything, minus 34, minus 57, minus 6, and whatever is left over is going to be 28. So 28, if my calculator is working, right? I cannot do the second row, so I'm going to go ahead and I'm going to do the first column, right? So if 34 have pets, 18 do not have pets, that total is 34 plus 18, and that gives me 52, right? This column, 97 total, take away the 57 that do have a pet, so that leaves me with 40 that don't. I could have done that in my head. 28 in this column have a pet and 15 don't. So my total there is going to be 43. This one is 8. 6 plus 2 is 8. And then the last one, 200 minus 125, is going to be 75 right here, right? Or you could just add down this row. So which statement should be true out of the 125 children that do not have a pet? So I'm looking at the statement 125 don't have a pet. Right here, if I look at the column that don't have a pet, there's not 125. So we know that that's wrong, or I did my math incorrectly, right? Out of 97 children who have one pet, so looking at one pet, so has a pet, there's not 97, right? The 97 is for one sibling. So that's where they get it. Out of 125 who don't have any siblings, so looking at 0 siblings, there's only 52, so that's incorrect. And then out of the 97 that have one sibling, so 97 that have one sibling, 40 of them do not have a pet, so that's correct. If you have questions, email me, Google Hangouts, Google Voice, let me know and I will jump on a call with you, okay? So a prize bag contains 4 country music CDs. So there's 4 there, 8 pop music CDs, 8 there, and then 5 classic rock. Okay, I always write these numbers out because I like numbers. I don't like words. Reading makes me tired. What is the probability of pulling out a classic rock CD and then without replacement, pulling out a country music CD, right? So we're looking at this. So classic rock, if I look, there is 5 classic rock CDs out of the total, which is 4 plus 8 plus 5 is 17, right? And then this is that symbol. That means we multiply. If it says or, then we would add them together. So we're multiplying because it says and then without replacing, which means you do not put it back. So you take out a CD and you do not put it back into the prize bag, right? So if I had 17 and I took one out, that means I only have 16 left. And our next option that we want is country music. There are 4 country music CDs, so that goes there. So there's 4 out of the 16 that are left. Multiply straight across, or you can simplify. 5 times 4 is 20. 17 times 16, I don't know what that is. 17 times 16 is 272. And when I divide this, so a lot of my students in 7th grade don't know, but it's 20 divided by 272. And you will get 0.0735, blah, 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 and it rounds, right? So here is rounding to the nearest hundredths. Cool. Halfway. Okay, burrito restaurant. Use the given table to keep track of numbers of different types of burritos and the kinds of beans that people requested, right? So this is nice because supply and demand, right? You don't want to buy too many beans, or else if the customers don't want it, then you're just left over with a lot of beans. So A is chicken burrito, and I like to label my tables. So here is A, this is chicken burrito. B is carne asada. C is black beans, and D is pinto beans, right? So which 2 events are independent? Looking at these right here, In order for this to be independent, that means that my probability of A given C has to be my probability of A or equal. This one, probability of A given D has to equal my probability of A. This one, my probability of B given C has to equal my probability, of B. And this one is probability of B given D has to equal my probability of B, right? So looking at the first one. Okay, so I'm going to start with the last one since we know that it's correct because the answer is checked right there. Looking at this probability of B, let's start with that. So if I look at B, there are 80 that want carne asada out of the total, which is 240 want the burrito. Okay, so if I were to do that on my calculator, 80 divided by 240, this gives me 1/3 or 3/10 repeating, right? Probability of B given D, right? So the given is D. If we are given D, that means we are only looking at D because that's been chosen already, right? Pinto beans have been chosen already. So when I write this, B given D, that first part right here, I'm looking at the B column, right? So that's the 24 out of what's given, the total is 72, right? So that's where they're talking about B and D. This is the overlap. If it's a Venn diagram, this is where it overlaps. And then you're given D, so you're only looking at D. So 24 divided by 72 will give you 3/10 repeating, or simplifies to 1/3 as well. These are the same, and because they are the same, they are equal, and that makes them independent. If I were to look at the other ones, let's do B given C, right? So if I'm given C, I am given black beans, then I want B, right? So probability of B given C would be 5 out of 45. Notice that this is my total, right? So 5 out of 45 is 1/9, and this will give you 1/10 repeating. Not equal, so not independent. If I look at the probability of A, that one's a simple one. So A is 83 out of the total, which is 240. 83 divided by 240 is 3, 4, 5, 8, 3, this is repeating. And then going on to the other ones, and the reason why I'm going over the wrong answers is because you're gonna need to know this, right? Probability of A given D. So if you're given D, you're looking at D, right? That is what's given, and you want A out of it. So this would be probability of A given D is going to be 30 out of 72. 30 divided by 72 is, and that's repeating, right? So not equal. And then the last one is A given C. So if I'm given C, I'm looking at C. I select A out of that. So probability of A given C is going to be 37 out of that total of C, which is 45. Take that on my calculator because my brain can't think. And this is 8, 2 repeating, right? So none of those are equal to each other. You know those are not independent, okay? And then this is the one where you really do have to do all of them and then see which one matches. And then hopefully you can guess which one is accurate to begin with so that you don't have to check the other ones. Okay, filling in the table because it's empty. So if I look at this, for my first row, if I'm looking at this row, 282 minus 104 minus 8 minus 96. This will give me 74, if my math is correct. Going down this column, 314 minus 99 minus 104. This gives me 111. Then I can do this row right here. There's other orders that you can do. 111 plus 10 plus 72 plus 88 will give me 281. Then I can double check to make sure that's correct by adding those together. If I continue looking at this row, so 815 minus 276 minus 196 minus 314, that gives me 29. And then I can go down here. So 29 minus 18, which is 11. And then I can go down here, which is 276 minus 88 minus 74, which gives me 114. And then hopefully I did my math right. So just looking at the answers that we have, out of all the 252 12th graders, so looking at the 252 12th graders right here, oops, right? How many rode in a car? So if I'm looking at car, that means that there's 114. Yay, I did some kind of math, right? Okay. Survey finds that 48% of the people identify them as fans of professional football. So I need to write this down. So football, oops. Football is 48%. 12%, oops, cars. 9% is both. Okay, so let F be fan of football. This is C. And that's it, right? So looking at this, what statement is true? Probability of F given C. So I'm looking at F given C. So this would be probability of F given C is the probability of F and C over the probability of C, right? So both, which is 9, over cars, which is 12. And when I do this, this will give me 75 hundredths, 9 divided by 12, right? Probability of C given F. So if I'm looking at probability of C given F, I'm looking at the probability of C and F over probability of F. So given F, that's given F, right? So looking at this one, this is going to be 9 over F, which is 48. If I do that, 9 divided by 48, this will give me, so that's not the answer that we want. I need more space. Probability of C and F is 0.09. So this is just turned into a decimal, right? Percents are always out of 100. 9 divided by 100 is 9 hundredths, right? So that one's correct. And then this one, C and F, is the same thing as F and C, right? So both of them, if they like cars and football, like if I like cars and football and you like footballs and cars, we're the same thing, right? And then probability of C given F, so that is 1875. Is that equal to F given C? So this is 0.75, 75 hundredths. This is not equal, so you know that that's not correct. Okay. Venn diagrams. These are terrible. Survey asked about who eats breakfast, right? So this is breakfast, right? And then these are the ones who eat cereal, right? So there are people who eat cereal not for breakfast, and there are people who eat breakfast that is not cereal, right? So those are these numbers right here. And then U is the people who don't eat breakfast or cereal, which is kind of weird. given that a person randomly chosen eats breakfast almost every day, right? So given that they eat breakfast, if they are given breakfast, then that means we are looking at this circle right here. Given breakfast. This is given to us. We are looking at this circle right here, okay? What's the probability that the person also buys cereal? So out of the breakfast people, this is how much is the cereal. So if we look at this, probability of cereal given breakfast would be probability of cereal and breakfast over probability of breakfast, right? Now, if you don't like those formulas, you're looking at how many people like the cereal out of the total. So this is 53 out of how many people like cereal total, which is 53 plus 11, which is 64. And that's where you get that one right there. Okay? Hopefully this helps. If you have questions, please let me know. I will walk you through things. I will clarify any understanding. I know that the lessons aren't the most exciting things in the world, but we're just going to get it done. Okay? And yeah, good luck.